Hey, hi and welcome back. Now let's start with this video, which is Introduction to Library Creation Process Part 1. So now let me tell you what you will learn in this video. So in this video, I am going to show you the process to create the library for IC555IC. So IC555IC is basically very popular IC, and I will show you how to create the library for that particular IC in this video. So the first point is symbol creation. So I will show you how to create the symbol for IC555IC, and then the second point is footprint creation method 1. So basically there are actually two different methods to create the footprint for any of the component of a library, and in this video I am going to show you how to create the footprint using method 1 for IC555IC. So this video is going to be about symbol creation and footprint creation for IC555 component. So that's how basically we are going to cover this video, and I am sure you will definitely enjoy this video. Okay, so now let's start with this video. So when we discussed the control panel, at that time I told you that whenever we have to create the library, at that time we have to go to files, then new, and then library. Okay, so this is basically the place where we create the library. And I also told you that library consists of a symbol, then footprint and a 3D package. Okay, so here I will show you how to create the library for IC555IC. Okay, and first of all I'm going to start with this symbol. So you can see here there is actually one button. So I'm just going to click on this one, and here I'm going to write the name of symbol, and it's going to be IC555. So I have given the name of symbol now, and after that I will click on OK. And after that I will click on yes. So now let's start with the symbol creation process for IC555IC. So this is basically the window where we create the symbol, and the tools that you see on the left hand side, you are already familiar with all these tools because we have discussed all these tools in schematic editor, and also we discussed them in layout editor. Okay, so we are going to use these tools to create this symbol. Now before we start with the symbol creation process, first of all I will take you to the datasheet of IC555IC, and there I will show you some important information which is actually required to create this symbol. So this is basically the datasheet of IC555IC which you can easily download from the internet, and this IC is manufactured by this particular company, which is Texas Instruments. So here I will not walk you through all the information which is given. Instead of that I'm just going to focus on the information which is actually required to create the symbol of IC555IC. Okay, so in every datasheet of IC you will see this particular section which is pin configuration and function. So this is basically the section to which you should refer whenever you create this symbol. Okay, and you can see here they have given the pin configuration of IC555IC. So this IC has got total 8 pins, and they have also given the names of all the pins. So the first one is ground, then the second one is trigger, then third one is output. So likewise they have given the names of all the pins which are actually present on IC555IC. And along with that, they have also given the information or the description for each and every pin. So this is basically the information which is important whenever we create the symbol for any of the component. Okay, so we are going to refer this particular information, and now let's start with the symbol creation process. So as we saw, there are total 8 pins in IC555IC. So I'm going to use this option, which is line option. And using this option, I am going to create the outline of a symbol. Okay, and you have to make sure that you are actually on this particular layer, which is layer number 94, which is symbols layer. So now I will create the outline of IC555IC, and we saw that there are total 8 pins in the IC555IC. So what I will do, I will randomly draw the outline for the symbol, and later we can adjust the symbol with the help of move option. Okay, so the outline for the symbol is now ready. Now it's time to connect the pins to this particular outline, and here you can see this is basically the option for the pins. So I will select this option, and later you can see here there are some other options. So by clicking on these options, you can actually change the orientation of this particular pin, or you can click on the right click of mouse to change the direction or the orientation of this particular pin. Okay, so like this you can do. Alright, and after that the next option is the pins are actually available in different forms. So I'm just going to select this none option, and later you can here select the width of the pin. So you can see, likewise you can select the width, and I'm going to select the middle, and after that display both names. So I'm going to select this particular option, and now let's connect the pins to this particular symbol. Okay, so I will total there are 8 pins, so I will keep the 4 pins on left hand side with a distance of 2 grids. So likewise I will do. Okay, and after that I will change the orientation, and again on the right hand side I will connect total 4 pins. Okay, so we are done with the pins connection, and after that I will click on escape. Okay, now it's time to give the names to these all pins. Okay, so let's give the names to all these pins now. So for that I'm going to refer the data sheet. So the pin number 1 is basically the ground pin of this IC. So I will right click on this point, and after that I will click on properties, and here I will write GND, and after that here the direction is going to be, so for that you need to refer this point, which is input output. So here it is written output, but generally, you know, whenever it comes to ground pin or supply pin, we actually provide the direction as power. Okay, so I'm going to select power here. So this is basically the power option, as ground pin is basically the power pin. So I'm going to select this option, and after that I will click on apply and then OK. So you can see here we have provided the name to this particular pin, which is pin number 1, and the direction is power. Okay, then the second pin is trigger pin. So again I will right click here, and after that I will click I will write the name of this pin as trig, and the direction for this pin is input. So I will select here input, and after that I will click on apply and then OK. Then the next pin is the third pin is output. So I will write output here, or I will just write out, and after that this pin has got a direction of output. So I will select output here, out, apply and then OK. The next pin is which is pin number 4. It's reset. So again I will right click properties, and then I will write reset here, and then apply. Okay, and then the direction for this particular pin is input. So I will select input here and then apply and then OK. And the next pin is 5th pin, and 5th pin is basically control pin. So I will go to properties and I will write CTRL here, which is basically the short form. So I will write it in short form or abbreviated form, and the IO is input. So I will select here input, apply and then OK. Then the next pin is pin number 6, which is basically threshold pin. So again I will go to properties, I will write threshold. So I will write THRE, and this pin is input pin. So I will select input here, and after that apply, OK. And then the next pin is 7th pin, which is basically discharge pin. So again I will go to properties, I will write discharge here or just dis, and after that again this is input pin. So I will select input here, apply and then OK. And after that the last pin is pin number 8, which is V plus pin. So again this is basically a power pin. So I will go to properties and I will write V plus here, and after that I will select power here, apply and then OK. Alright, so I will maximize this window. So almost our symbol is ready, but what I will do, I will create some space here. So I will use this move option, I will move this border, and later I will use this group option. I will make the group of all these pins. So you already know this particular procedure, and then move group, and later I will move these pins to the edge of this symbol. Okay, so our symbol is now ready, and it's time to save this symbol. So I will click on save, and now let's navigate to the location. So whenever we import the new symbol or whenever we create the new symbol, at that time we need to store it in this particular location. So I'm going to store this IC555 symbol in this location, and I will change the name to PC underscore IC underscore IC555. Alright, so we have given the name to this symbol, and after that I will click on save. And what it is saying, PC already. Oh, okay, so I already have this particular symbol. So let's overwrite this one. So I will click on yes, and after that we are now on the library creation window. So this is how basically our symbol look like: ground, threshold, output, reset, control, threshold. Sorry, this one is trigger, discharge, and V plus. But here if you see, we have not given the description for this IC. So what I will do, I will double click on this symbol option, and here you can see there is actually a provision to provide the description for this IC. Okay, so at this moment I will just give some small description. As this particular IC is a timer IC, so I will just write IC 555 timer IC. Okay, alright, so we have given the description, and after that I will click on OK, and later I will click on save. And from here you can go to table of content. Okay, so this is basically the table of content. It is also called as table of content. Here is our IC 555 IC and a small description for this IC. Now it's time to select the footprint for this particular IC, right? So again I will go to the datasheet. So in datasheet, if I go to the first page, you can see here they have written the packages. Okay, so this particular IC is available in different packages: SOIC, PDIP, then VSSOP. And I will show you how to create the footprint for this SOIC package. Okay, in the same way you can create the footprint for this package and VSSOP package. Okay, so I will show you how to create the footprint for SOIC package, which stands for single outline integrated circuit, and it actually represents the number of pin. Now, in order to create the package for this particular IC, you have to go to import 3D package. So you click on this option, and after that you can see here there is one option which is add from web. So I'm going to show you how to add the footprint for this IC from the web. So this is basically the library for different footprints. So you will get the footprint for resistor, you will get the footprint for capacitor, you will get the footprint for different standard packages. Okay, so in the same way I will just search here SOIC, and then I will click on enter. So you can see here there are actually different options, and these are basically the footprints for SOIC package, but we are interested in SOIC package with 8 pins. Okay, so this is basically the SOIC package with 8 pins. Then likewise there are SOIC package with 16, 16, 14, 20 likewise. So this particular option looks suitable, so I will just click on add, and this particular package will now be added in the in this window. Okay, so this is basically the 3D package for the IC 555 IC, and later this is how basically the footprint for IC 555 IC look like. Okay, and then this is the symbol. Okay, alright, so that's what I wanted to discuss in this video. I showed you the process to create the symbol. Later we imported the footprint from the web, and also the 3D package for this particular footprint. Okay, and in next video I will show you how to create the footprint by using method 2. Okay, alright, so that's what I wanted to discuss in this video, and I hope that every single thing that we discussed in this video is now clear to you. And if you still have any kind of doubt, then definitely you can reach to me. Okay, now I will see you in the next video, which is about introduction to library creation process part 2. Okay, so I will see you in next video now.